Today, just an introduction. Most weeks I'll try to incorporate some of the news with regards to combustion, emissions, and energy conversion. Let's kind of run through just the big picture, and then we'll discuss a little bit of the details. Today I'll give you a little history. It was right before the pandemic. I actually did some emissions measurement on the Ford Model T from a century ago, and I gave a brief at the Environmental Protection Agency with some history. So I'll give you a little bit of that history that I shared with our agency here. Weeks 2, 3, 4, 5 are the most quantitative. And so combustion thermodynamics, that'll be air-fuel ratio, heating value, flame temperatures, and some exhaust component calculations via equilibrium. So what happens is emission components will form at really high temperatures, and then as they expand through our different engine systems will often quench. So we can get a good indication of those via equilibrium calculations. A lot of this we'll do by hand. I think there's some great value there. And then we'll spend a couple weeks on kinetics, the rates at which different emission constituents form. So those 4 weeks, 2, 3, 4, 5, are the most quantitative. What I'll encourage you to do, there's some great examples. And then each of those 4 weeks, I'll also do a number of examples. Combustion can get complicated quickly, but I do think there's some great value at doing some of these foundational calculations just to understand the bigger picture. So that's really the core of and again, I think we can do most of it by hand. There might be 1 or 2 questions where Excel or MATLAB could be helpful, and when we get there, I'll provide some direction. So then we'll look at fundamental flames that in gas-fired combustion, weeks 6 and 7. That's really the industrial application. That is, for example, important now. We've really come back to a great emphasis in mining some important materials for EV applications. In fact, maybe one of my slides, I think today, it's interesting. The amount of energy that goes into making an EV can be about 3 times that of a gasoline vehicle. And that is just due to the many components that are necessary in the batteries and the motors. So doing that in an environmentally conscious way, of course, will be important. So that is really foundationally industrial flames. We'll spend a couple weeks on gasoline engines and combustion. As I mentioned, certainly that varies around the world, and we'll see some statistics. I recently saw in the U.S. here about 7% of new car sales are electric. That's coming up slow and steadily. It's quite a bit higher in China. I think it's about 1/4. And in parts of Europe, also much stronger than here in North America. But again, getting some of those battery and motor materials does require some high temperature processing, and that's where I do believe industrial combustion will still be quite relevant. But gasoline engines, they're inexpensive, and I truly believe in my lifetime, I think for most of your careers, at least the first few decades, we'll still see a lot of gasoline combustion, but I do believe that will diminish over the next 10 to 20 years. It is the lowest cost energy conversion, and so I think around the world there still is a place with personal mobility for that. And that was largely my focus at Ford. There are some problems. We'll see what's called engine out emissions, and that, of course, led to the smog problem in the 50s, 60s, 70s. But those engines today are our emission control system, which do add a little bit of cost, but we can reduce those problematic emissions by 2 or 3 orders of magnitude. It really, really is quite good. Then we'll spend a couple weeks on diesel. This is the area that I personally believe will not diminish in extent, especially long-range trucking, railroads, and marine applications. I just cannot see electrification in many of those domains. The emissions control with diesel has followed, it's some decades, behind gasoline, but over the last 10 years, it has improved tremendously. So we will look at that. We'll spend a week with gas turbines, and that is another area. There are marine-based gas turbines, but of course, the majority and number are in aviation. Aviation, hard to electrify. And so there are, of course, alternative fuels, but also we'll look at the transition in gas turbine combustor technology. In the recent past and into the future, it's largely pre-mixing air and fuel as opposed to diffusion flames historically. So emissions have come down, and they will continue to do so in the aviation gas turbine world. I believe coupled with some synthetic or e-fuels will be the way that we can get to low carbon or carbon neutral in the coming decades. The last week I have coal, poor coal, but it's in America, I think it's about 20%, maybe 20-25%. Power generation, and depending where in the world, that can be more or less. We'll see some coal composition. It is heavy carbon, right? So heavy CO2. It's certainly problematic from the carbon dioxide perspective. And so I have a week there, but also have some other ideas for our last week together. So that's the big picture. So again, that the early half is fairly quantitative. We'll have a few homework assignments and some examples. And then really the second half is much more qualitative. We'll look at different technologies and approaches to reduce emissions.